All right, we're going to talk about factoring the sum or difference of perfect cubes. So this is going to be things in the form of like, a cubed minus b cubed or a cubed plus b plus b cubed. So with this, as with the sum or difference of perfect squares, or actually with the difference of perfect squares, uh, it's extremely important to be able to recognize when a number is a perfect cube. So I always like to begin by talking about what numbers are perfect cubes. So let's do that. I've got 1 cubed is 1, 2 cubed, 2 times 2 times 2 is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729, and 10 cubed is 1000. So being able to recognize these numbers, so 1, 8, 27, 64, 125, 216, that being able to recognize these numbers as perfect cubes is extremely helpful. And although I wrote it up here, I'll write it again down below. What we're going to do is we're going to, in order to do this, we need to actually just directly apply a model. So if I've got a cubed plus b cubed, this is going to turn into a plus b times a squared minus ab plus b squared. If it is the difference of cubes, so a cubed minus b cubed, this is going to be a minus b times a squared plus ab plus b squared. Now, so what you're going to do is you're going to identify what numbers or what expressions make cubed would be in here, and then we're going to fill in the rest of this. How I usually instruct people to do this is I want you to notice a couple things with this. You notice that it's always a and b. So once you know what numbers cubed would make these here, you're going to fill in this first binomial, and then we're going to fill in the trinomial, and we're going to use this a and this b kind of as a guide to go through here. Also, one of the things that you should do is you should note the sign here. Notice that that whatever is happening in here, this is the same sign. This one is the opposite sign. And this last one is always a plus. So when you're doing this, we are going to use SOAP. Same, opposite, always plus. So here is our methodology. What we're going to end up doing when we do this is we're going to use SOAP to set up the framework. 2, we're going to identify our factors, and fill in the binomial. And then 3, we're going to fill in our trinomial. And with that, that first term is our first term squared. Is that first term from our binomial. Our middle term is going to be the product of our two terms from our binomial. And then our last term is our last term squared. So let's take a look, let's take a look at an example and do one. How about we start with, we'll start with y cubed plus 27. And this right here is, well, these are both cubes, and this is plus, so we're going to set up our binomial and our trinomial. Same sign, opposite sign, always plus. What cubed is going to be y cubed is, well, it's y and a 3, because 3 to the third power, 3 cubed is 27. Now, our first term, so I'm going to take this first term and square that y, so I'll have y squared. Our middle term is going to be these two times each other, so y times 3 is 3y. And our last term is our last term squared. 3 squared is 9. We're done. These look really intimidating. And then you realize that they are, all you need to do is apply that model. Let's do it again. I'm going to do a tougher one. I'm going to do 8x cubed minus 125. Okay, well, this one looks really intimidating until you realize that it's just applying the model. We use our SOAP. So remember, same sign, opposite sign, always plus. And we have to figure out what will go into this first binomial. So I know I'm going to have an x in there because x cubed is going to be x cubed, and 2 to the third power is 8. So 2x times 2x times 2x would be 8x cubed. And a 5. 5 cubed is 125. This first term is this first term squared. So 2x times 2x would be 4x squared. My middle term is the product of these two. 2x times 5 is 10x. And our last term is that 5 squared, 25. All done. These look intimidating, but they're quite straightforward. Last example here. Let's do, how about I do something that might require an extra step. And I'm going to go with, let's say we've got two x cubed plus 250. That one looks scary, and this is a perfect, well, that's a perfect cube. 2 isn't. 250 isn't a perfect cube either. But I could factor out a greatest common factor first. If I take out a 2, I'll have x cubed plus 125, and then the rest of that is fairly easy to do. We set up our structure here. Same sign, opposite sign, always plus. Ask myself what two numbers will go in here. So x cubed will be x cubed, 5 cubed is 125. First term is the first term squared. Second term is the product of 2. Last one is the last term squared. This other 2 is just going to follow us on down, and we're done. Alrighty, that's all we've got for right now. We'll see you in the next video.